Alright, so we're going to try this video one more time. Worked hopefully pretty well the first time, so hopefully the second time will go just as smoothly. A couple people had questions about oxygen isotopes and trying to figure out ways that we know how climate used to be well before we had thermometers. So I am going to talk about the oxygen isotopes, so I'll draw that on the board. And I'll talk about a couple other things that are known as climate proxies. A climate proxy is, again, a way that you can figure out what climate used to be way back in the day. We're talking hundreds of years, thousands of years, even hundreds of thousands of years in the past. So first, oxygen isotopes. This is one of the best ways to figure out what temperatures used to be like on the planet. This goes back many thousands of years, and it all starts with the ice cores. Ice cores gathered from mostly Antarctica, because there's been ice there for a really long time. You can get a lot of information out of those. So first things first, there's two different types of oxygen isotopes. Got a chalk over here. You have oxygen 16 and oxygen 18. Oxygen 16 is a little bit lighter, oxygen 18 is a little bit heavier. So let's assume that this is a continent, and here we have the ocean. So we can imagine if O16 is a little bit lighter than O18, and I'm simplifying a little bit here, but O16 is going to be evaporated first. So let's assume we evaporate the O16 first, and then it gets stuck on ice as an ice sheet on this continent. So there's a little bit of ice on the planet, and as a result of the little bit of ice on the planet, you get a lot of oxygen 16 in those ice cores. Now let's assume it cools off. Well, there's no more O16, or less O16, to evaporate from the ocean, so now we're evaporating more O18. When you evaporate more O18 now, that will be here. The second area of ice. So my point here is that if you have more O16, there was less ice on the planet. If you have more O18, there was more ice on the planet. So it's just an amazing thing how just looking at the isotopes of oxygen can give you a perfect indication of how much ice was on the planet and thus the temperature. So that's how oxygen isotopes work. There's many other climate proxies as well. Tree rings is a good one. Trees grow a little more if it's warm and wet. They grow less if it's cold and dry. So you can look at those rings. It sounds really good. In practice, it's not quite that accurate. You know, if you have insect infestation or other things that impact trees, but still, it's not too bad. It doesn't go back that far. You can look at air bubbles inside these ice cores. Incredibly, you could figure out exactly what the atmosphere was composed of literally hundreds of thousands of years ago by looking at those air bubbles. Beyond that, you can look at the bottom of the ocean floor, look at stuff called ooze, coccolithophoric ooze. Basically what you look at here is the shell thickness of microscopic critters. That shell thickness is very closely related with ocean temperatures, so you can look at that. You can do pollen analysis. If you get mud samples, you can look at various types of pollen that used to be present. So if you had tropical species of plants living in an area, 30,000 years ago, you could assume that it was warmer back in the day. So there are many other climate proxies. Those are just a few. But again, it works really well. And as a result, scientists have a very good estimate of what climate used to be like many years ago. So as always, if you have any questions, just let me know. Take care.